Hello everyone, my name is Sarah Knudsen, and today I'm going to be trying to present about 3 years of my life in research in about 40 minutes. My project is examining the impacts of double-crested cormorants on catfish aquaculture in the Black Belt of Alabama and Mississippi. So let's get right into it. So throughout this presentation, I'm going to be walking you through what we did in this project, starting with who, the why, the what, the how, and then the wow. So the who being who's involved in the project, then why did we do this project, what are we doing in this project, how did we do it, and wow, so what's the results. But first, the who. The primary species of interest in this study is the double-crested cormorant. They are a fairly large diving water bird, so they dive below the surface of the water to catch fish, and they are a piscivorous species, eating only fish, but they're highly opportunistic. So they're going to eat basically any fish that they can fit in their mouth, and they can eat up to a pound of it per day. They're also migratory. So around April through October, they are within their breeding range in Canada and the Great Lakes region. And then starting around starting around October, large populations of cormorants migrate to the southeast and coastal regions in the United States. Specifically, the Mississippi River is an important overwintering area, as well as other rivers in this area, for overwintering. The other who in this project are the catfish farmers of the Southeast, and specifically Mississippi and Alabama, which are the two primary producing states in the United States. Within that, there's two different regions, the Black Belt and the Delta. The Delta region is the most producing of the two regions, and it is the most intensified. So farms in this region typically stock hybrid catfish in single batch production. So a hybrid catfish is a cross between a blue catfish and a channel catfish, and they typically grow a little bit faster, so you can harvest quicker. And they're stocked in single batch, which just means that one cohort of catfish fingerlings is stocked and then grown within the pond till it is ready for harvest. Whereas in the Black Belt region, which is this crescent right here, farms typically stock channel catfish, which are more slow growing and often cheaper, in multi-batch production. So they're continuously going to be stocking catfish in a pond so that they can continuously harvest off of a pond. And that is the who. Now, why? Why are we looking at this? Well, as I said, cormorants spend October through April overwintering in the southeast, specifically around the Mississippi Delta region and coastal regions. And they are a fully fish-eating bird, so as you can imagine, this is not going to play out very well on catfish farms. And as things tend to do, it comes down to money. Most U.S. catfish sold in the United States were produced in Mississippi and Alabama. And right now, a lot of farms are struggling due to low return on investment. There's a high upfront cost associated with catfish farms, and competition from imports, as well as high feed prices right now, reduce profitability. And cormorants add on to that, so a lot of farms will bring on additional personnel throughout this winter season to try and scare cormorants off of ponds so that they can retain some of their investment. Another big factor of that is truck maintenance, so gas and tires, because catfish spines can and will pop a tire. You can ask Michelle Straw over in facilities. I've gone through about 3 over the course of my study. And ultimately, a lot of farms are just going out of business because of low return on investment. So ideally, we can understand the factors that are driving cormorant depredation in the Black Belt specifically, inform management practices, and thus improve harassment outcomes and hopefully improve profitability, because these farms are important both nationally and for local communities. And cormorant depredation is very frequently studied in the Mississippi Delta region because, as I said before, it is the highest producing region. but it's less studied in the Black Belt region. A lot of the assumption is that it's similar, but there are specific regional differences that might affect cormorant depredation different than the Black Belt region. So, industry infrastructure, as I already kind of touched on earlier, channel catfish versus hybrid catfish, multi-batch versus single batch, as well as farm and management characteristics and overall landscape characteristics, because the Mississippi Delta is a lot closer to the Mississippi River than the Black Belt region. The Black Belt region has a lot of other rivers nearby, such as the Warrior and the Tennessee Big B, for example. So that's the why. What are we doing and what do we know? So we know that in natural systems in the Delta region, cormorants have a highly diverse diet, but the species primarily depends on what's available to them. Studies have examined the diet before and seen shad, drum, sunfish, bass, and crappie. These are typically slow-moving and schooling fish. So a channel catfish is not going to appear very commonly in a natural system diet because oftentimes they're up under logs, if you're familiar with noodling, and they can be much larger and typically on the bottom of ponds or waterways. But in the Delta region, so around catfish aquaculture, the percent composition is heavily skewed towards catfish, followed by 40% shad. So in the Delta, where there is a lot of this aquaculture, there is a higher incidence of catfish consumption. And the most significant consumption is between February and March on these ponds, and we see a similar trend in the abundance of cormorants on ponds, also in the Delta region. So there's kind of this bimodal peak. There's two different peaks in cormorant abundance throughout the year, one in November and then one in late February to March. And this makes sense as you think about cormorants migrating down the Mississippi River from their migrating range. There's going to be a high influx of cormorants before moving further south to coastal regions or even staying on farms. But then we see this plateau where, again, a lot of cormorants will continue further south. And then on their way back up from towards their breeding range, they're going to be stopping over on these catfish aquaculture ponds. And maybe there's a larger peak here because breeding is a very expensive undertaking for a cormorant, for all species, but in this context, a cormorant. So catfish are going to provide a quick hit of high protein and high fat feed. And we know that there are management factors with some farms that have been observed to have higher occupancy associated with them. So levee ponds, gridded ponds that we often see in the Delta versus like a watershed pond, which we often see in the Black Belt. I'll show you an example in a second. As well as higher occupancy with increased fish abundance. That makes sense. Increased occupancy on larger ponds with increased distance to forest. Now, that one doesn't initially make intrinsic sense because a cormorant dives below the surface of the water. They're not like typically associated as a perching species. Why would distance to forest matter? So, as a diving bird, cormorants cannot be very buoyant, so their feathers get waterlogged and then they have to dry their feathers. And if their feathers are not fully dried by the time they need to take off, that's going to increase the amount of time before they can gain altitude. So potentially the proximity of forest to a pond might make a cormorant feel trapped, like they could not escape. Increased distance to activity centers. Again, this makes sense. Cormorants don't want to be disturbed. Increased occupancy with distance to other ponds, as well as fingerling, so smaller fish, and increased fish density. There's also landscape factors, so Studies in the Delta region have observed a 9% increase in occurrence for each 10-hectare increase in nearby aquaculture. They've also observed increased incidence of catfish and cormorant diet from roost sites or just other sites closer to high densities of aquaculture and further from natural foraging areas. So, where there's areas of high density aquaculture, their catfish are going to play a more important component of the diet versus a farm that is closer to a natural area. So there's evidence that cormorants would prefer to use a natural area, but again, are highly opportunistic. And roost sites have been a reoccurring theme in a lot of the literature, with increased proximity of a roost site being observed with increased numbers of cormorants and occupancy of cormorants on aquaculture. This is a image that I took from Google Earth. This little oxbow right here is actually a wildlife management area, and this is exactly what a cormorant would like to see to roost on. It's got these trees, probably a lot of trees and water, right next to the water. So they like to be near waters where they feel safe. And it is right next to this aquaculture facility. Now, it doesn't need to be that close, but some studies in the Delta have shown that cormorants travel on average 15 to 20 kilometers between night roosts, and in the Black Belt it's about the same, 19 kilometers, with an average of 7.9 kilometers between roosts and daytime foraging locations, that is. And as promised, here are some ponds in the Black Belt region versus the Delta region. The first thing I want to point out here is that the camera is 15 kilometers from the surface of the Earth in both of these images, so that kind of helps us get a feel for the size of the ponds. So that's one thing I want you to take away from this, is that ponds in the Black Belt region are often a lot larger than ponds in the Delta region. The second is that Delta region ponds are often very gridded like this, whereas in the Black Belt, while there are some gridded ponds, many of them are more watershed based because they rely more on surface runoff and overall water from the land to fill ponds rather than pumping, which occurs in the Delta because, again, right on the Mississippi River, so the water table's higher, pumping costs lower. And then the third thing I want you to take away from this is that these ponds are a lot more spread out than in the Delta region. Again, there's definitely ponds and farms that break those general rules, but that's just a rule of thumb. So, now what is our goal? Our goal is to quantify cormorant abundance, fish consumption, and economic impact on black belt catfish aquaculture. So the economic analysis part of that is going to be handled out of house. That's a little out of my wheelhouse, but I did do the diet and abundance. So in chapter 1, cormorant diet, we will be addressing what are cormorants eating by species, percent weight, and number. What are the patterns of catfish consumption? So the seasonal timing. Are there differences between male and female cormorants, catfish species, and catfish sizes? And then for the cormorant abundance chapter, how many cormorants are on these black belt region sites over the course of a winter season? And then why are cormorants selecting the ponds that they are? And I identified several management and habitat and temporal variables that might influence cormorant selection of a pond based on what's been done in previous literature in the Delta region. So that is the what. Now we move on to how. First, I had to select sites. So I acquired a digitized map in ArcGIS from previous literature of all aquaculture within the Black Belt region. And then you can kind of see there are little hotspots of catfish aquaculture, and I broke those down into zones. And we did this because we needed to maximize the amount of aquaculture that we could survey during the aerial surveys, which we'll get to in a second. So I selected 30% of the farms within each of these zones, and then I ensured that it was going to be representative of farm size within the zone. After that, we conducted aerial surveys every other week between October of 2023 and April of 2024, and then October of 2024 through April of 2025. And typically we flew around 500 feet, maybe less if there wasn't any houses or anything below us. And we flew about as slow as we could while remaining in the air. And we started around 1 hour after sunrise and ended 1 hour before sunset, so an 8-hour window, which coincides with cormorant foraging hours. They are a diurnal species, and also FAA regulations. I also took images on a subset of ponds to capture the true number of cormorants on a pond versus what I counted, which is going to be observer bias, and we will get to that here in a little bit with a fun little exercise. Okay, so after the aerial surveys, I had to conduct pond and farmer surveys. So this just informs what the pond type was. Was it levee? Was it watershed? The batching strategy, single batch, multi-batch, as well as species stocked, oxygen level in the pond, stocked head per acre, and size stocked. I also included a variable called months since stocked. So for each survey period, I would count the number of months since that pond was stocked. So in survey period 1, it might be half a month, which would be the month that it was stocked. And then the next survey period, if it was another month out, would be 1 month. And so on and so forth. And this just kind of helps us have an idea of the size of the most recently stocked catfish fingerlings. Because, again, in multi-batch production, you can't just say there's one size class in a pond, because often there's multiple. Alright, and then I spent a very long time in ArcGIS extracting pond size, farm size, as well as distance to each roost site and distance to activity centers, adjacent pond index, road index, and forest index are going to need a little more explanation. I'll get into that right now. So for each of these, I created a 35-meter buffer around each pond. And then for adjacent pond index, it's not a true index, I just counted the number of ponds within that 35-meter buffer. So pond 69, for example, would have 2 ponds within 35 meters. Pond 71 would only have 1 pond because it doesn't quite reach this pond. Adjacent road index was a little more complicated. So this is a 0 to 4 basis, a 0 being there were no roads within 35 meters, 4 being there were roads on all sides of the pond that extended at least 50% of the pond. So pond 71, for example, it was counted as 1 for road index, because this does not extend down 50% of this pond size here. And this is not a road, it's a levee. It kind of looks like it might be used for access, maybe a UTV or something like that, but it's not a daily use road. We used similar guidelines for forest index, but for forest I counted a tree line as long as the crowns were touching of each of those trees. And I did that because, as I kind of explained earlier, it's not so much the amount of forest behind the proximal face of that forest to the pond, it's if it's there or not, because it would just impact a cormorant's ability to clear and take off. Okay? And this is just a general overview of all of the variables that were included here. Alright, so for diet. After each aerial survey, myself and a team from the USDA went out to 10 farms that I randomly selected from the survey that I observed cormorants on during that survey. And the goal was about 5 birds per farm per collection period, so the goal was about 50 birds per collection period, and that just almost never happened. And And then once I got the birds back to a necropsy lab, we removed the stomachs and esophagus, identified, measured, count, and weighed all prey items within them. So then I took the total lengths of fish when possible. So for this fish, this is a catfish, we were able to get a total length, but often the head was not there, or it would be missing this caudal fin here. So we would have to obtain a partial length. Usually that was from the point of the posterior point of attachment of the adipose fin here to the very tip of the caudal fin here. And then we use regressions to reconstruct the total length of a catfish. Okay, so then for fish that were complete, we were able to have total weights, but then for partial fish, we had to use regressions to obtain, we had to use equations to obtain the total weight from reconstructed total lengths. We use t-tests to assess these relative biomass metrics, and ANOVA and Tukey HSD post hoc testing to examine monthly trends in the amount of biomass consumed. Okay, so we want to get as close to truth as possible in our counts with aerial surveys, and there's been multiple documented sources of bias that prevent us from getting truth. So we identified 3 and accounted for 3 in our survey. The first is observer bias. Did I tend to undercount or overcount birds? Turnover rate, how many of individuals left aquaculture and were replaced by other separate individuals on the landscape? And then availability, how many cormorants were there but were not seen? And this is that little exercise that I talked about doing with the observer bias. So can I get a volunteer observer? You. Perfect. Thank you. All right. So what I want you to do is I want you to count the number of cormorants in this image. Try and break it down into about groups of 10. Ready? Okay. You get that? That's okay. I've got an image here. It's definitely hard when you're moving around and also you almost hit a cormorant. So if we break this down into groups of 10, 10, 10, 10, 10, and then 3 up here, that's about 83 cormorants, you might guess. But when we actually count the image, there's 93 cormorants. So that's a difference of 10 cormorants. So then what we can do is take the average or proportional difference between what I counted during my flights to what was actually counted in the images. So that's the raw count times this factor here. Then the average daily turnover rate. Then the adjusted count. So ultimately adjusted counts are the raw counts from the plane times our observer bias times turnover times availability. And then with those corrected counts, I had summed those up to each survey date, and then converted survey date to days through winter for each year. So day 0 and 214 were outside of the window, so day 0 would be the last day of September, and then day 1 would then be the first day of October. Day 214 would be the first day of May. Or 213, because year 2 was in a leap year and nothing could be straightforward. And then I set those day 0 and day 214 or 213 to 0. And we used a quartic polynomial regression to fit for each winter. This was to account for that double peak that we saw in cormorant abundance. And then bird use days are the sum of the predicted daily abundance across winters. Okay. So this is where it begins to get a little more complicated. So in our counts, we observed overdispersion and possible zero inflation in the counts. And what that means is there were a lot of times there were no birds on a pond. There were also times that there was over 300 birds on a pond. A lot of times it was 20, 30, 50. So there's a high level of variance with a lot of zeros in the data. So we examined a couple different models and we came to the conclusion that a hurdle model would be the most appropriate fit because it allowed us to model occupancy separate from abundance. So occupancy being 0 or 1, a cormorant was there or it was not there, separate from the amount of cormorants that were there, so all the counts that were greater than 0. And this resolves that zero inflation issue, and it also allows the variables that affect occupancy to differ from the variables that affected abundance. Oh, thank you, reminder bird. It was all AIC approved. And so this is our final global model here. And that is a very large model. And we can't just plug and chug that into the model. We have to simplify what we're doing. So the first thing we did was to check if there is any collinearity between the variables, and we suspected that there might between batching strategy and species stocked, as was observed in previous literature. We similarly observed that. Again, hybrid catfish are often stocked in single batch production, and channel catfish are often stocked in multi-batch production. So then I had to decide if I wanted batching strategy or species stocked in my variable set. I ultimately selected batching strategy because batching strategy would be more encompassing of the management factors and variables influencing that pond rather than species stocked. It makes more sense. A cormorant's not going to be, ooh, hybrid catfish. Oh man, I've really got to have a hybrid catfish. They taste so much better than a channel catfish. It's really like a Wendy's fry versus a McDonald's fry. There's just no comparison. Okay, so then we focus on each component separately. So for the abundance component, we begin by looking at the full variable set and starting with we do a trial run removing the least significant variable to that model. And if removal of that variable improved model fit, it remained out of the model, and then that became the new baseline model to compare the rest to. So we would go down the list comparing what would be the best dropped at each stage. Ultimately, we're left with these variables here, and then we turned our attention to the occupancy component, and a lot fewer variables were ultimately removed than in the abundance component. So these are our final models here. This is the simplified models, or rather model components. And from that, we can get the occupancy probability from the occupancy component and the expected abundance when a pond was occupied from the abundance component. And from that together, we can get the expected use. And that really means, like, so pond A, for example, had 80% occupancy and pond C had 80% occupancy, but pond A had 50 birds in conditional abundance, whereas pond C only had 10. If I said pond C before, I meant pond A had 50 conditional abundance, pond C had 10. So the expected use will look like 40 for pond A and 8 for pond C. And these are just made up numbers just to exemplify what expected use means. Okay, so from that we get estimates of effect, bootstrap confidence intervals, and graphs. And a bootstrap confidence interval is just a confidence in our measure of the estimate. So that's the how. Now we get into the fun stuff, the wow, our results. So just a little bit of overview. There were differences between farms in the Black Belt region of Mississippi and the Black Belt region of Alabama. So the average pond size in Mississippi was 2.9 hectares, and mean size of ponds in Alabama was 4.6 hectares. We also saw a pretty equal split between hybrid and channel catfish use in Mississippi versus a much higher use of channel catfish in Alabama with lower hybrid. And then we saw reflective multi-batch and single-batch use in both of those states. All right, so results for the diet. Year 1 and year 2 up top, we see the same trends, just a little bit different in the numbers. So just looking at the pooled across both years, we saw mostly shad in the diet, followed by catfish and then sunfish. So sunfish being like bluegill. And then silver sides are like this big, mosquito fish are like this big. There was one cormorant that ate about 53, I believe it was, mosquito fish. So we had to measure and weigh all of those. That was a long day. But so of those catfish that cormorants consumed, around 79% were channel with 21% hybrid. And cormorants ate around 2.1 channel catfish per cormorant, weighing 102 grams, and an average of 1.4 catfish per cormorant, weighing 70 grams. Hybrid catfish per cormorant. Overall, we saw a similar size distribution, but a lot more variability in the channel catfish sizes than in the hybrid catfish sizes. And this again makes sense because channel catfish are often in multi-batch production where there's going to be multiple size classes in a pond. So all of this data was collected from 275 cormorants who donated their bodies to science. We thank them. This is what that looks like on one page. And of those 275 cormorants, around 67% were male, and they consumed around 56% of the total catfish biomass. But we saw a pretty even split in what male and female cormorants were eating. There was not a difference between channel or hybrid and channel or hybrid between males and females. Similarly, the average length consumed was a little different, a little higher in males, but it was not statistically significant. We also saw that's bimodal distribution, those two peaks, in the amount of catfish in cormorant diet based on mass. So our first peak was in October, with the highest peaks between March and April, February, March, and April. But we don't have the best estimation for January because we only collected 4 cormorants during that sample period, and that's because we did not get as many flights in as we wanted to. So in year 1, we got fewer flights in than in year 2, which also means that we had fewer outings. So in October, we had no flights during year 1. In January of year 2, we had no flights. But in the abundance, we also see that rough peak. But due to a lack of data points in year 1, it's a little bit rougher of an estimate. Okay, moving on to the spatial variables from the hurdle model. So there is a lot going on in these upcoming graphs. So right now, what I'm going to do is just ignore what the variable relationship is. I'm just going to walk you through what each aspect of these plots are. So first of all, plot A is expected cormorant. So that would be like the third model there from availability, from abundance and from occupancy. Graph B is the predicted occupancy. So this variable was not selected for, or it was not retained in the abundance model. And when we get there, there will be 3 graphs. Okay, so there's also a dashed line and points. The dashed line really indicates what does the model is the isolated expected effect of that variable. So if all ponds had 5 months since stocking, what do we expect that relationship to look like? If all ponds had 10 months since stocking, what do we expect that relationship, the expected cormorant occupancy, to look like for those ponds? And then the point is, what does the model predict for ponds of that actual variable along with all of its other variables? So for a pond 10 months since stocking, what is the cormorant occupancy that it expects and expected use? Oh, sorry. And then these tick marks down here are rug plots, so that's where we actually have data for. So for months since stocking, we saw a general decrease in expected cormorant use and occupancy as the months since a pond was stocked increased. For farm size, we saw the opposite trend as farm size, so that is the cumulative number of cormorants, the number of ponds and their pond sizes added up, and that's the farm size. But we also have a lot more farm sizes in these smaller ranges with very few farms in these higher farm size ranges. But generally, as farm size increased, we expected or saw that the expected cormorant use increased, as well as the predicted occupancy, but it was not retained in the abundance component. We saw the opposite trend for mean size of stocked channel catfish. As the stock size increased, we generally saw a decrease in expected cormorant occupancy and use. The same for aeration. As aeration increased, we saw a general decline. So for forests within 35 meters, we saw generally an increase in use. Now this might just be a factor of that means that the pond is more isolated, but we don't have a great estimate for number 4. That's why the confidence interval here looks so weird. There was only 19 ponds that had that had forest on all 4 sides of a pond. Alright, so now we're getting into the variables that were selected in both occupancy and expected abundance. Pond area was the most significant variable in both expected occupancy and expected abundance, given occupancy. As pond area increased, we saw a significant increase in the number of expected cormorants on a pond and the expected occupancy. So similarly for the expected use. Okay. Similar trend for distance to nearest activity center. So as the distance from an activity center increased, we saw increased cormorant expected occupancy use and abundance. We saw the opposite trend as the amount of road within 35 meters increased. We generally saw a decrease in expected occupancy and abundance, and therefore expected use. And neighboring ponds, it varied between both occupancy probability and expected abundance. So we generally saw a decrease in the expected occupancy of a pond as the number of nearby ponds increased, but the opposite for expected abundance. So overall expected use kind of leveled out, it remained about flat. So in summary, we generally saw that the trends in the black belt did follow what has been observed in the delta, that cormorant diet is opportunistically driven and that more males than females used aquaculture with equivalent consumption and peak consumption between February and April of catfish. The same carries over into peak abundance that we observed. We also saw that pond size was the greatest predictor of cormorant occupancy and abundance, and different variables affect occupancy and abundance. So the ideal pond based on cormorant occupancy was a large pond close to other ponds that are on larger farms, and ponds that are further from human activity with fewer nearby roads and low nearby forest cover. For abundance, cormorants were more abundant on large ponds close to other ponds and ponds that were further from human activity with fewer nearby roads. And I just wanted to thank all the catfish farmers of Mississippi and Alabama for letting myself and other strangers come on their property and shoot firearms, as well as the USDA Southern Regional Aquaculture Center for the funding for this project, and the USDA National Wildlife Research personnel, and all the other undergraduates without whom I would not have been able to collect cormorants and all the data that I did. And at this point, I will take questions. Thank you. Chicken mug.